Okay, so today we're going over optimization, right? So this problem can appear in a lot of different ways, but let's just go through some examples of it, okay? So, let's say a farmer is gonna build a fence around his pasture, okay? But let's say that pasture is next to a river and you don't need fencing along the river. So how would you maximize the area of your pasture, okay? All right, and let's say we restrict it so that we only have 1,200 feet of fencing, okay? So we have 1,200 feet of fencing. Okay, and we're building this fence around a pasture where that's the river right there. Okay, so I'll just go there. Okay, and we don't need fencing along the river, and this is going to be a square pasture, rectangular, excuse me. Okay, so we'll call this guy L. We'll call this guy L, and why not, we'll call this guy W, okay? So the way to do optimization problems is you set this problem up and you want to get it as a function of one variable, and then you can take its derivative and set it equal to 0. Remember from the last class period that to find maximum and minimum values, we're going to set the first derivative equal to 0. That'll give us our critical points. Okay, so what do we have from this thing so far? We have that 2L now plus W is going to equal 1,200. Okay? And then we have to consider what are we really trying to maximize inside of this problem. Okay? What we're trying to maximize is the area inside of here. So we're going to get that A, the area, is going to equal L times W. Okay. Now we're going to try to get the area as a function of one variable so we can take a derivative with respect to that variable. So we could say, well, okay, I could say that W is equal to 1,200 now minus 2L. And now I'm going to plug W into our area formula. So the area is going to equal L, now multiplied by 1,200 minus 2L. Okay? Okay, let's simplify this up a little bit. So that would equal now 1,200 times L minus 2L squared. Okay, so now we have our area as a function of one variable. So let's take the derivative of the area with respect to that variable. All right. So the derivative of the area with respect to L, okay, that's going to be, well, the derivative of that one is just 1,200. Okay? All right. And the derivative of L squared would be a 2L, so we would get an extra 2, so this would be minus 4L. We can set that equal to 0. Okay? And now we're going to solve for L. Well, if I move the 1,200 to the other side and then I divide by 4, I'm going to get that L is going to equal, sorry, that's a 2 right there, 1,200 divided by 4, which is going to equal 300, and that's going to be in feet. Okay. Okay, and then we'd say, well, you know, W would then equal 1,200 minus 2 times 300. Okay, so that would turn into 1,200 minus 600. Okay, so 1,200 minus 600 would give us 600 feet. okay? So 300 as L and 600 as W, that is going to give you the maximum area. Those are the dimensions that give the maximum area.